Hi folks, so in this video we're going to discuss sigma notation. And so that's the type of notation where you'll end up seeing a little symbol that looks like this. Now that's the Greek letter for sigma, and it talks about a repeated sum. It has an initial value, and that's usually stated by creating some variable like n or I, and an initial starting value, like often 0 or 1. And then it has a final value. And we're just going to use a final value of 5. Now, what it does is it cycles through an expression with a variable of n starting with 1, and then the next time it goes through it'll go to 2, and then the next time it goes through it'll go to 3, and the next time 4, and next time 5, and then when it hits the final value it stops. So let's give this an expression to go through. We'll have it just go through the expression n. And so what will this end up equaling? Well, let's write out each individual term. So if we start from n equals 1 and we go up to 5 of n, the first time we go through this expression, well, n will equal 1, so we'll just have 1. We're done through that expression for the first part, so now we'll put an addition sign because we're going to add. And now the next time we go back through, n will have increased and will become 2. And you can see that this is going to just simply increase again to become 3, once more to become 4. And we've just got another way to write how to write out the sum of the first 5 numbers. And so, of course, we can add those up, 5, 10, 15. And so that would be evaluating an expression like the sum of n from n equals 1 to 5. Let's try another example. So let's consider the sum from I equals 1 to 5 of 2i. Hit pause for a second on this video and think about what this might actually become. And now that we're back, we'll take a look at what this becomes. So the first time we go through our expression is 2 times I, and I started at 1, so it's going to be 2 times 1. Then we'll go through again, and it'll be 2 times I, but now i's increased, so 2 times 2. And then 2 times 3. And then 2 times 4. And then 2 times 5. And so when we add all these up, we'll be adding up 2 plus 4 plus 6 plus 8 plus 10. So in other terms, our general term just added up the first 5 even numbers, not including 0, of course. So when we add these up, what do we get? It looks like 10, 20, 30. Now let's take a look at another example. Let's take a look at the sum from n equals 0. So we're going to start the first time we go through at 0 now to 4 of this expression, negative 1 to the power n times n plus 1. And so when we go through and actually break this down term by term, and I'll just do the first 2 terms and the last term. So the first term is negative 1 to the power 0 times 0 plus 1. The second term is negative 1 to the power 1 times 1 plus 1. Then we'll have a number of other terms as n becomes 2 and then 3. And then our last term will be negative 1 to the power 4, 4 plus 1. So this negative 1 to the power n actually causes our signs to alternate. Because remember, anything to the power 0 is just equal to 1. So our first term is going to be positive 1 times positive 1 or positive 1. But our second term will be negative 1 to the power 1, which is negative 1. So it'll now be negative 1 times 1 plus 1, or 2. Our third term would be positive, our fourth term would be negative, and our fifth term would be positive again, because negative 1 to the power 4 would just be positive 1 times 5. And so you can see we've got, again, our series, much like our first one, but our signs have alternated because of this negative 1 to the power n portion. And so summing this up just gives us 3. So that should be a little introduction for how to use sigma notation.